So example B, now we're actually going to throw some values in here. Now, again, A is 1 and B is 0. No, sorry, not B. P is 0, Q is positive 1. So I can already tell you a little bit about my graph. Specifically, my vertex is 0 and 1. A is positive, so I'm opening upwards, which means it's still a minimum. The axis of symmetry goes through my x value of my vertex, so it's still x equals 0. Opening up, my range is from not 0 now, because it's my y value of my vertex that determines my minimum. Or you can even list it at 1 to help yourself out. From 1 upward, and my domain is negative infinity to positive infinity. So again, I'm just dealing with my intercepts being my unknowns. In this particular case, again, I can solve for my y-intercept no problem. It's going to be 0 squared plus 1, which is 0 plus 1, or just 1. Y equals 1. So I can put this all on my graph. Again, okay, now I'm going to scale it down for the rest of these. I'm going to make my y scale change by 2, and then my x scale can change by 1. Okay, so I've got, instead of being at 0 and 0, I'm going to be at 0 and 1 for my vertex. Now the rule was I went over 1 and up 1. Now because my A value hasn't changed, I haven't stretched it at all, that stays the same. When I went over 2, I went up 4. That stays the same. It's just that now I'm starting at positive 1 instead of 0, so I'm ending up at 5 instead of 4. For 3 squared is 9, so that's what should be happening, but I've got that plus 1, so I'm actually going to end up at 10. And so my parabola is actually the same general shape. The curve hasn't changed other than I changed my scale, but vertically it hasn't stretched and compressed, it's just literally taken it and moved it up. When I look at my graph, I look for x-intercepts, I actually have none in this case. Example C is very similar. So what I'd like you to do is pause the video and give it a shot yourself, because we're still dealing with A is 1, P is 0, but this time Q is negative 2. So how is that going to change it? So give it a shot, pause the video, and then you can continue on and I will explain. Okay, did you try on your own? Things you should have gotten. Our vertex is at 0, and this time it's going to be at negative 2, which means my axis of symmetry is still at x equals 0. Okay, again, x value of my vertex is my axis of symmetry. My A value is still positive, so it's opening upward. So that means it has a minimum at y equals negative 2. Again, because that's my vertex. That means that my range is still starting at my vertex, so negative 2, and opening upward. Domain continues to be unrestricted. If you solve for your y-intercept, in this case it's going to be 0 squared minus 2. That disappears. 0 squared is still 0, so y equals negative 2. So I can put this all on my graph. Again, I'm going to stick with the same scale for the rest of our examples, or most of them anyways, unless I get to the last couple I might change. Negative 1 and 1. Always label your scale. Okay, and y scale, again, does not need to be the same as your x scale, so choose appropriately. From here, 0 and negative 2 is my first one. I haven't stretched or compressed, so it should still follow the same trend. 1 squared is 1. Okay, it's just that I'm starting from below my x-axis, so I only go up 1, and I end up over here instead. 2 squared is 4, so I should end up 4 higher than my vertex. 3 squared is 9, so I should end up 9 higher than my vertex. Here. And technically 4 squared is 16, so I should end up 16 higher than my vertex, which is 14. Let's see. Yes, 2, 10, 12, 14. There we go. Oops, no. 10, 12, 14, 6. Yeah, no, that's right. 14. There we go, because I moved it down 2. So it should be at 16, down by 2, so 14. And from here, I'm going to connect my parabola. Oh, I've miscounted somewhere. 2, 4, 6, 8, 10, 12, 14, 16. Yeah, there we go. Knew those points looked wrong. And you might be able to get to that point where you can just spot that they're wrong. But until then, just make sure you count very carefully. You can actually label all these. It just starts to look really sloppy on my graph. If I continue to do that, it just fills it up too much. Looking here, well, I've got my x-intercepts crossing kind of in a funny spot, so I might guesstimate that my x-intercepts are at around, probably negative 1.5 and maybe positive 1.5, but that's just a guesstimate. When we're graphing, it's a little bit hard to tell. But B and C, we see we're only got Q as the only value listed there. So it's taking the exact same shape, the exact same curve, and it's just moving it either above the x-axis or below the x-axis. So that's how Q affects our graph.